Ayo, what's up guys? BabyBear4812 coming at you one more time today with problem 767 reorganize string. So the reason I went with this problem is because I noticed in the past couple days it climbed up on the Amazon and Google recently asked questions, kind of in that top 50 on Leetcode. And what I think I'm going to do from here on in is to be a bit more, I guess, diligent on staying on top of the really new and fresh frequently asked problems by these companies so that you guys are getting the most relevant content possible. So if you have any requests, as always, drop them in the comments down below, or you can email me, contacts in the description, which is babybear4812@gmail.com. So with that said, let's have a look at this problem. We're given a string S, and we need to check if the letters of the string can be rearranged so that no two characters that are the same are ever adjacent to each other. And not only do we need to check if it's possible or not, but if it is possible, we actually need to output a variation of that. There could be more than one unique answer, so it doesn't really matter which one we output, but we need to output any possible result. Excuse me. If it's not possible, then we will output an empty string. We're told also that we are given lowercase letters in the range of, or the length of the word being 1 to 500, so we're always going to have a legitimate input. We don't need to worry about any bogus entries or, I guess, any absurdly long strings either. Now, they told us in the example here that we've got two potential strings, AAB and then AAAB. So let's think about how we're going to actually do this. There are two components, and sorry, let me say this one's good, this one's bad. There are two components to this problem that we want to think of, which I kind of alluded to earlier. The first component that we need to think about is whether or not it's possible to rearrange a string in such a manner. If it's not, we can cut our losses and say return an empty string like the problem told us to. Although if it is, then we need to worry about the slight headache of actually putting a string together. This second step might be a bit easier if maybe if you're coding in a language like Java or C++ that do have built-in string builders. With something like Python or JavaScript, we need to get a bit more creative because strings are immutable in those languages. But that's all right. You'll find that maybe my code is it's a bit more verbose. It'll be about 30 lines long. Sorry. Whereas the explanation on Leetcode is a whole lot less than that. But when I reviewed their method after I submitted mine, and I didn't really find it intuitive, so I hope through this explanation that the code then will kind of reflect that very step-by-step thinking without any sacrifice to time or space complexity, of course. So circling back here, we said this one was all good, this one was no good. So the question is why? Well, to determine whether or not it's possible for us to actually create a string or rearrange a string so that no two characters are adjacent to each other, no two identical characters are, what we're curious about, strictly speaking, is actually the character that occurs the most frequently. In this case, A occurs the most frequently. And we can say, well, I can separate the A's this way, and I can then stick the B in here. In here, we've got 4 characters in total. We got 4 characters, 3 A's and 1 B. No matter which way you skin the cat, there's no way to put 3 A's in here such that one of them isn't touching. Right? So we can have A, and A. Well, that's not going to work. And maybe we tried A, and A like this. Okay, well, that's also not going to help. And I think the only last combination we can have maybe is A, and A. So there's nothing that we can do there. We've got too many A's given what the length of the string is. And so that then begins to beg the question, like, how many A's can we have? How many A's is too many? The answer to that depends on whether the string is actually even length or odd length. So let's think about this. If I've got a string of length 3, the highest count of any character I can have would be 2. So if I think about filling every other slot in with a certain character, I'm going to cap out at 2. This is the best that I can do. If I've got 4, it's going to be the same thing. Either I can have 2 here, or I can have 2 here. If I've got 5, I can now have a third character. If I've got 6, again, I can have only 3 here, or only 3 here. And so this is the question that you want to ask yourself when you're trying to determine what's the actual pattern on how many characters, on whether or not this is possible. So the first part is to say, all right, I'm concerned with only the most frequently occurring character. The second is, how many times does that a character occur with respect to the length of the string? So if you, I'll kind of leave it to you if you to maybe jot this exercise down by hand and prove it to yourself if you didn't see it immediately. But if we got an odd length string, then we can have the length of the string divided by 2. So and we take the ceiling function of that, meaning that if I've got a length of 3 divided by 2 is 1.5, but I can have up to 2 of the same character. So we're going to round it up. With the even characters, we can have the total length and divided by 2. So if we had like 4 characters, we said that we can have 2 A's here or 2 A's there, and that's the most we could do. So technically speaking, if I want to group this together, in fact, I could always just take this length divided by 2 and just take the ceiling of that, and that'll give me the maximum occurrence that I can have. And so what I'm going to do is I'm going to say that the maximum character frequency that I can have, so maybe I'll call it max frequency, is going to be equal to the ceiling of the length of S divided by 2. What we need to do then for the first part of this question is to say, let me take the character count of all the characters in this string, and maybe as I do that, I can keep track of what the maximum frequency is. And once I've finished with all my counts, I can say if my maximum frequency exceeds this, as it would here, where we've got a length of 4, and 4 over 2 is 2, so it's the ceiling of 2, but we've got 3 A's, then in that case we're going to return false, or rather we're going to return an empty string, as we realize there's no way that I can modify this. So this is all going to be step number 1. Otherwise though, if I complete step number 1 and I realize that it is possible in fact to have some variation of the string, I now got to go through the hassle of doing this. Now this kind of thinking that I just explained, this has come up in other problems, and before I recorded this video, I couldn't for the life of me remember where I'd explained this, because I think there was a video on my channel where I did talk about this. So if you've seen that video before, let me know which one it was down below, because it's driving me crazy right now. Otherwise, do let me know what other problems you've seen this in, because I know they're out there on Leetcode. So the tricks we're learning here will definitely be applicable to other problems that you can come across in your interviews. Now, that was kind of the first step that we saw. The second step involves actually building this thing out. So typically, when we're counting frequencies of characters, when we're limited only to the lowercase English alphabet, one neat trick that we can use, and that I personally like to use quite frequently, is to create an array with exactly 26 entries and initialize each frequency to 0. So there are a total of 26 entries, one representing each letter of the alphabet. So this will be for your A's, this will be for your B's, this will be all the way through to Z. As we do this, once I come across every character, if I've got an A, I'll add 1 here, and then I'll add another, and then I'll add another, and then B, I'll add 1, and eventually we get this count. And again, as we're doing this, we can keep track of a maximum frequency variable if we'd like. What's nice about this is that no matter how big the string, our space complexity is always O of 1 here. It's always O of 1 because at most we can have 26 entries. So it's kind of kept together nicely and efficiently. However, what this doesn't help me with in its current form is actually building the string. Because what I'd like to do, if I had these certain character counts, so let's say I had A's and B's here, I know that when I'm filling this out, because of this relationship here, because of how I can only have up to half or half plus 1, in the case of an odd length string, maximum occurrences of a character, to guarantee that I can actually create this, I need to start filling from the front and filling every other cell or empty slot here. So imagine that I had a string that looked like A, B, C. All right. For me to fill the A's in, the only way for me to do that, in a worst case scenario where I have the maximum possible number of A's, I need to start by filling at index 0, and then index 2, and then index 4. If I also had a D here, for instance, then I could still stick with the same logic. So sure, maybe in this case I could get cheeky and do it in every other cell, starting from index 1 instead of 0. But we've got no benefit to that, since we're guaranteed to be able to create a string no matter what when we start filling in from index 0 and jumping across every other cell. Once we've actually made it through every other, and I keep saying cell, I kind of mean like character, and if you can think about this as like a result string, and I'm trying to build it and plop the characters in. Once I get to the end of the string, I can then say, let me now jump back to index number 1. So I've gotten all these. Let me jump back to index number 1 since I'm at the end and start filling in from 1, and then again jumping 2 at a time. So B and then C. I will begin my first walkthrough with creating the string by starting at index 0 and filling in my most frequent character every other step. And of course, once I run out of occurrences of that, I'll start filling in the next character and so on. Once I reach the end of the string that I'm trying to build, I jump back to index number 1 and then start filling in every other step again. And that way we're going to create a string of length n, and all the characters, all the identical characters, will always be separated by at least one other character. The reason we're guaranteed they'll always be separated is because we checked that we do not have more than the ceiling of the length of the string over 2. If we have more than that, then again, we won't even be entering this step. So, this is kind of step number 2. We won't be entering step number 2 at all because it's simply not possible. So by the time we enter step number 2, we verified that it is doable. Then we're guaranteed to be able to create a string using this method. What this method means, though, is that I need to be able to see kind of every character at a time. I need to be able to know which order to fill them in. Particularly, we're going to need to know which character is going to need to go first, or the most frequent one. To do that, what I'm going to need to do, and this is going to bring my time complexity up to, I guess it'll be n log n. What I'm going to need to do is to say, or I guess, sorry, I'll put the complexity down below because I am only sorting 26 items here actually, so I don't think that the complexity would be that bad. So I'll put in the description with because I haven't thought about it as much as I should have when I'm recording this now. But once I sort this, I'm then going to need to say, okay, let me plop in this many instances of A, this many instances of B, this many instances of C, and so on. And of course, we do that from highest, most occurring to least occurring. However, you notice, as follows. If I had something like, in this case, the frequencies are easy, but maybe I had a bunch of zeros, and then somewhere I had 6 occurrences of one character, and then 7 of another, and then 0, and then 2 of some other character, and so on. If I rearrange these integers as they are, all I'm going to have is integers. I'm not going to know which character they refer to. All right. If I rearrange just as is and I count my characters as I were, I'm not going to know which character had which frequency. The simple solution to this, at least the one that I ran with, was I said, let's just store the characters. So let me say this is going to be character A and its frequency is 0. This is character B and its frequency is going to be also 0, so on and so forth until I get to Z. Its frequency is also 0 for now. I haven't counted anything yet. And then when I sort it, I'm going to sort purely by the frequency, and then I'll always have access to the character right there. This is how I thought about it. I did it with the nested array. You could use a tuple. You could probably use another method that I didn't necessarily think of. So do let me know down below if you have any other suggestions on how to do this in a different way. This is just what I felt was most intuitive. And maybe to be clear, actually, instead of actually storing the character as a string, what I've done is I've stored, I guess it would be its ASCII code. So in Python, I'd just be using kind of ord of A. And I'll show you guys how we do this in the code. But really, I'm storing the ASCII code, and then when I spit it back out into here, I'll just take the ASCII code and convert it into the character very quickly, and then fill in the rest of the string. So that's it, and I'll show you in the code how we're actually going to build the string in Python. That's it, kind of for the theory. Let me know if you have any questions down below. But otherwise, let's jump into the code and start typing this thing out. So we are going to start by we're going to start by giving ourselves a bit more space because I can't make my head any smaller, and then that really takes up space. So we're going to start by saying let's kind of create that count array, so the one that I described right here at the bottom. I'm going to go ahead and call that character counts. And what we said was, each of these character counts is going to have some nested array, and we're going to have 26 of them. So let's say for I in range 26. And for each one of these, we said that we're going to want to have some character and then its count, which is going to be initialized at 0. I want my first character to represent an A, so it'll be A. So ord of A will be, and I believe this is the ASCII. I believe We can check up. I'll look up the documentation later and correct myself in the description. But it's certain code related to that one character. And what I'm going to want to do is I'll just say maybe I'll take ord of a plus I, so that when I'm filling my first entry here, it'll be ord of a plus 0, which is going to be the character a. We then take ord of a plus 1 on the next step through the iteration. We'll have the character that represents b. Ord of a plus 2 will then give us character that represents c, and so on and so forth all the way through to z. What I'll also do, as I alluded to, is I'll create a maximum frequency variable, so that when I walk through my counts and I say I can just ask if maximum frequency is greater than the ceiling function of the length of s divided by 2, then what I'll do is I'll return the empty string. And again, I'm doing that based on the constraint that they told me if it's not possible to return an empty string. And this piece of logic right here is what I described earlier when we determine that what the maximum count of any given character I can have is. Now, I want to continue by actually filling in these character counts. And so what I'm going to do for that is I'll iterate through every character in the string. So for every character in S, I'm going to make a reference to the actual character index. So I'll say that the character index is going to be equal to the ord of that character minus ord of a. So that if my character is a, this would refer to index 0. Or the first entry here. If it's ord of b, the character b, it'll refer to ord of b minus ord of a, which is 1. There's 1 distance between them, so it'll be index 1 and so on and so forth. I'm going to be accessing this a couple times in this loop, which is why I want to keep a variable to do it. So what I'm going to say is I'm going to say character counts of this character index. That's going to give me access to this inner loop, and then in the second, not the inner loop, excuse me, the inner array. And in index 1 of that is where we store the frequency. So I want to take that frequency and increase it by 1. I can then say that max frequency is simply going to be the maximum of the max frequency, and the character counts at that index 1. So sorry, I think I kind of mumbled there. At every step along the way, I want to check to see if I've beaten my maximum frequency with this new update that I made. If I did, let's update the maximum frequency. If not, we'll just leave it as it was. And that's it. That's how we're going to be checking. We're going to be collecting the count of every single character. And we're going to keep the maximum frequency only so that it's really easy for us to say whether or not we have too many of these. Hypothetically, you don't need this maximum frequency. You could then loop through the character counts array and check them all one at a time. And you could say something like for I in range no character counts, and then you could say if character counts of I of 1 is greater than this, then return an empty string. But I thought that it would be a bit simpler just to keep some sort of variable and then do this clean check. Up to you, tomato tomato. Now, if it's not the case, then this is where we actually need to think about how we're going to build this string. First thing we needed to do was to say, like, I've got to know which characters to start filling in first, so I'm going to need to sort the counts array. So I'll say character counts dot sort, and what I'm going to do is, since I want to sort it by the second element, I'm going to do a lambda function here, and so the x will represent any given one of these inner arrays, or they could be tuples if you wanted to make them tuples. Really makes no difference, and we want to sort them in decreasing order by frequency. So I'll say in decreasing order by frequency. So within this tuple, if you will, we're going to take the frequency and sort downwards. I'm also going to create a result array here. And what I'm going to do is I'm going to create a result array here. And, maybe for fun, I can just pretend I'm going to have an underscore for every character. And we're going to do this for every character that's in the string. And what I'm going to do at the end is I'm going to need to return this string, so this array, and what I'm going to do is I'm going to start filling the array elements in one by one. Since I can't mutate a string, they're not mutable in Python, I'm going to fill in the appropriate indices in this character array and then join them all together at the end. So I'll return an empty string dot join result. What the empty string does is it just says join every character without anything between them, just plop them right together. Maybe I'm being cheeky here. We don't need this. I can just leave an empty string, and that'll be a placeholder for every character. Now, what I'm going to want to do is I'm going to write some sort of method just so I don't duplicate my code. And in this method, what I'm going to want to do is start filling filling this result array with the appropriate characters at index 0, 2, 4, 6, all the way until the end. And once I reach the end, I then want to jump back to index 1 and then fill 1, 3, 5, 7, and so on and so forth, kind of like how I described, down here in this model. And so what I'm going to do is I'll create a method called, I think I called it create string when I did it earlier. Whether or not that's appropriate, I'll kind of leave for you to decide. You can come up with something more clever if you want to. And in it, I'm going to want to pass the actual character counts. That's one thing. The other is the result array, which I'm going to need to modify directly. And I'm going to need to pass in 2 more items. So one that I'm going to want to put in is going to be result index, and the second is going to be a character counts index. The reason I'm doing that is as follows. This result index will actually tell me which index I'm at as I'm filling that results array, and I'm going to want to jump it up 2 units at a time. The character counts index will stick with every character in our sorted array until so as I'm kind of throwing these letters in, I'm going to decrease the total frequency that we have left. If this was a 3, I'm going to fill in an A in the appropriate spot. I'm going to jump up 2 units. This will now become a 2 because I've gotten rid of one of them. I'll fill it, jump 1 over, the next, I'll fill in another A. I'm now down to 1 more A and so on and so forth. So what I'm going to want to do is to keep an index of where I am in this character counts array so that I can actually make this, so I can fill it in appropriately. And so what I'm going to do is I'll define this thing in just a moment and how we're going to build this. But what I'm going to want to do is to call this method. And so I'll call it self.createString, and we're passing character counts result. The result index I want to start with will be 0. I want to start filling in from 0, and I'll have some character counts index, and I'll get to that in a second. And then I'm going to want to make the exact same call. So maybe I may not be too clever here. I'll copy paste. Except I'm going to now want to start from 1. All right. Initially now, so if you were to try to run it like this, assuming this method works, and this is an issue that I ran into earlier, I realized that if I let's say I'm filling in my characters, if I jump out of the loop that we're going to create early, the character counts index will never actually be moved along appropriately, and so it'll kind of go out of bounds, if you will. And I think maybe I jumped prematurely into explaining that disclaimer before actually creating this method for you. So what I'll do for now, and trust me here, I'll walk through my reasoning for this in just a moment, but I'll create an index here to represent that character counts index, and we'll pass it in. We'll pass it in here both times. And so what I want to do when I want to create the string is I can only really loop through, again, starting at either 0 or 1. I want to loop through while my result index is less than the length of the result. So while I'm actually pointing at a slot in this array, I'm going to need to do some work to this thing. And when I say work, what we mean by work is this, is I want to say, look at the current character that I'm on. So I've sorted my frequencies, and I'm looking at a character right now. As long as I have some sort of frequency to that character, so if it was, if it occurred once or twice or 3 times, I need to start filling it in. So I'm going to say while in our char counts at the index that we're interested in, which is character counts index, and 1, remember, represented this over here, the frequency, while that's not 0, and again while the result index is less than the result, and again here, this is the greater than 0 is implied. I don't usually write these out just to keep the code a bit more verbose. This just means that, or to keep it more succinct, sorry, this just means that it's a non-zero value. What I'll have to do is I'm going to say, let me take that result that I'm at, that result index. So I'll say result at result index, and let me put the character that I want into that slot. Okay, so I'm going to put the character that I want into that slot. That character is going to be the following. At char counts, we're currently looking at the char counts index, and since I want the character itself, I'm looking now at the 0th index right here in that inner array. Remember, we said that this would give us an ASCII code or an equivalent code to that character. So I need to take that code, which is all this, and I need to turn that into the actual character. So I'm going to do that with char, which is kind of the inverse operation to ORed. Now that I've done this, this means I've filled in one of my slots in the result. I'm going to want to jump ahead by 2 spots. And what I'm going to want to do is I'm going to want to take this character that I was just at, and I'm going to take its frequency, and I'm going to decrease it by 1. Okay. Now, if I actually get to 0, so let's say that I've filled this in, and now I no longer have any characters left. I no longer have any frequency left for this character that I was just at. I put them all in where I needed to. What I'm tempted to is just to say, okay, let me take my character counts index, character counts index and move that up by 1. All right, so that would be fine. However, what I'm not taking into account here is what's the reason that I jumped out of this while loop? Is it because of this? Or do I still have, potentially a character left, but I've gotten to the end of my result? If I've gotten to the end of my result and I don't recognize that, then when I try to fill it back in, I'm going to run into like an indexing issue. I'm going to be out of bounds. So what I'm going to say is if the result index is less than the length of the result, so if I still have space in my array to keep filling items in, then I want to move the character count up. However, if I reach the end of my result, and maybe I still have characters left, and I'll show you an example of this, then I don't want to move that character count up. I want to keep filling in this character when I get to the other side. So, for instance, if I got something like, let me think here. Let's say I'm trying to fill in a character, and I've got, let's say I've got A, and now I've got 2 B's. So I've got maybe A, B, B, C. Okay. If I fill in a, sorry, I think I'm confusing myself here with an example. If I, let's see, I even just had this. So I had A, and then I had 2 B's. Okay. I had A, B, B. Once I fill in my 2 A's, I'm gonna notice my character count would look something like this. I'd have A2, B2, and then a whole bunch of zeros. Kind of like high school all over again. Once I fill in these, this will be down to 0, okay? I'm then going to want to jump up 2 units, and so do it this way. We'd have 1C. I'm going to fill in a B here, okay? B is my next unit. I'm now pointing at the B right here with my character count index. Since I've gone too far, I now want to jump back to index number 1, meaning I'm going to want to make a second call to this function. However, I'm going to want my character counts index to keep pointing where it is so that I can continue filling the B's. Okay? And that's the reason for which I need to check and only move this up. I only want to move the character count index up if I can actually, if I'm actually done filling this character. That's the only time I want to do that. Which is the same reason why right here, what I wanted to do when I created this variable and initiated at 0 is to say, let me modify it through this first iteration that I'm going through. Let me fill in as many characters as I can, and then it'll be stuck. Maybe I'm on my 2nd or 3rd or 4th character. Once it's done and I've gotten to the end of the result string, I want to make this new call to this new variable. And I want my character count index to continue where I left off. If I didn't create this here and I just started it at a 0, for instance, then I wouldn't know where to continue the rest of my character counts as I went through them. So that's why I kind of initialized this variable here. And that's all the code that we actually need to make this happen. And so let me just try to run it really quickly and make sure that I didn't mess anything up, which I did. So it's yelling at me here. It says it doesn't like what I did, and I'm not sure why for high range 26, because I forgot the equal sign. Equal signs are important when you're assigning values. So is correct spelling of your variable names. Maybe that's what happens when I talk too much. And I'm going to submit this, and perfect. So the 2 that ran here, they were 32 milliseconds, and they were like 80 percentile. So don't freak out about the runtime here. As a recap to everything we did, the 2 parts of this problem really were one in determining whether or not it's actually possible to create this string. If it isn't possible, then we said let's cut our losses and we're going to return. If it is, however, then we need to go through a bit of a hassle of creating this array. Again, I believe that I'm sure there are other ways of doing this, of creating the string. This was the way that I found most intuitive, and kind of doing these two calls here. It's what made the most sense, and I kind of coded it out in how I originally perceived it. If you have another way to do it, if you have any suggestions or questions, drop them down below as always. Other than that, again, do let me know if you have any other questions you want me to answer, either down below or email me at babybear4812@gmail.com. And I will see you guys in the next video. Peace.